Dr. R. Soumya, Assistant Professor, Department of Electronics and Communication Engineering. Today we are going to see the subject control system. The subject code is EC3351. Unit 2 is time response analysis. Under this we are going to see the topic time response. Since time is used as an independent variable in most control systems, it is usually of interest to evaluate the system response with respect to the time. The response given by the system, which is the function of time to be applied excitation, is called time response of the control system. The typical input signals are impulse signals, step signals, ramp signals, parabolic signals. The typical input signal, first let's see the ramp input signal, that is r of t equal to t when t is greater than or equal to 0 and 0 when t is less than 0. So while taking the Laplace transform, we will get r of s equal to 1 by s square. Next one, step input signal. So r of t equal to 1 when t is greater than 0 and r of t equal to 0 when t is less than 0. So r of t, while taking the Laplace transform, we will get r of s equal to 1 by s. Next one is parabolic or acceleration input signal. So r of t equal to t square by 2 when t is greater than or equal to 0 and 0 when t is less than 0. R of s equal to 1 by s power 3. While taking the Laplace transform for r of t in parabolic signal, we will get r of t is equal to 1 by s. Let us see the test signals. The input signals are step input, ramp input, parabolic input and impulse input. So r of t is a into t. For parabolic input, the r of t signal will be at square by 2. For impulse input, the r of t value will be del t. While taking the Laplace transform for the step input, we will get a by s. For the ramp input, the Laplace transform is a by s square. For parabolic input, the Laplace transform is a by s power 3 and the impulse input, the Laplace transform is 1. Classification of time response, transient response and steady state response. So transient response is defined as the part of the time response that goes to 0 as the time becomes very large. So limit t tends to infinity, y of t is equal to 0. The time required to achieve the final value is called transient period. Next one is the steady state response. The steady state response is the part of the total response that remains after the transient has died out. For position control, the steady state response when compared to with the desired reference position gives an indication of the final accuracy of the system. If the steady state response of the output does not agree with the desired reference exactly, the system is said to have a steady state error. Thank you.